In order for a firm to produce a good or service, it must convert inputs to outputs. Let's take a closer look. The relationship between a firm's inputs and outputs is known as the production function. Libby has an example that she'd like to share with us.
Let's say Captain Von Trapp and Maria open a school for the singing children. They only have two costs, that of the rooms they use to teach and the allowances they pay their children to teach the other kids to sing. Also, let's pretend that there are no more free rooms in the house, but they can only use these rooms for teaching singing due to the decorations. That makes it a fixed input. However, they can choose which children to use for it. There's only one variable in the short run. All are variables in the long run.
That's right. So, since they can't easily change the rooms that they're using, the rooms are a fixed cost. They have to use these rooms and pay what in this case would be the economic cost, the opportunity cost for these rooms, regardless of whether they use them or not, or how many children they teach singing. However, they can change the amount of their children that they use as teachers, meaning that their labor is a variable cost. This allows labor to be a variable cost while the rooms are a fixed cost. But remember, that's only the case in the short run, because in the long run, everything is a variable cost.
For a better look and a closer look at this lesson, let's head over to the chalkboard.
And we're back to the chalkboard. Thank you very much, Libby, for sending us over here. So, next up we're going to be looking at another one of these graphs. Graphs. Yay. So, the first part of the graph that we're going to need to do is the Q output, which is going to be on this axis, and then we'll have our Q input, which will be on this axis. Now this is our total product curve, and the graph looks exactly like this. Yes, that is the graph for our total product curve, which is showing us how the quantity of output depends on the quantity of the variable input for a given quantity of the fixed input. Now, the marginal product. The marginal product is the additional quantity of output produced by using one more unit of that input. Right there you have it. That's the definition. Feel free to write it down. Now, we have an equation here, the marginal product equation, which is going to show us that the marginal product is going to be part of the relationship between the delta output and the delta input. Now it's going to be those divided by each other and drop the equal sign in right there. That's right, there's our equation. The marginal product equals the change in the quantity of output over the change in the quantity of input. Now usually that quantity of input will be labor, so it's quite often considered the marginal product of labor. Just something to remember. So here's our graph for that. We've seen something very similar to it with almost every marginal graph we've looked at in AP Economics, but this one is going to be for the marginal product, which is going to be your Q output and your Q input. Now, one thing you're going to need to know for this is the Law of Diminishing Returns, which is a concept that if one factor of production, the number of workers, for example, is increased while other factors, machines and workspace, for example, are held constant, the output per unit of the variable factor will eventually diminish. Although the marginal productivity of the workforce decreases as output increases, diminishing returns do not mean negative returns. The number of workers exceeds the available machines or workspace. So there you have it. That's going to wrap up this episode of AP Economics. We'll see you next time, guys.
Well, that's everything, and this is the Fox family driving off into AP Economics.